biggest call out that I can remember from last semester, because I got a lot more communication from guys last semester, was the things that I took away that I think could make your life the most easy, and hopefully you guys already figured this out, is the graphing, because again, I can't say it enough, you always have access to Desmos. Always. So there's no reason you would not have a calculator at any point. So we want to use that to our advantage. So if they give you a function, even if you have to solve it, and it's just a bunch of equations, or if it's the equation by itself and they give you that function and you have to go find the inverse, I highly recommend graphing it, because they should be a perfect reflection over the x equals y, or y equals x. So this diagonal line, the 1-to-1 diagonal line that runs this way, they should match perfectly. And what I mean by that is wherever it crosses here, so like this one would be 6, 0, then it should be 0, 6. I just colored over it, so now I'm probably not going to have great intersections. So this would be 0, -3. So that means that -3, the coordinates flip. They're the exact opposite. So they are the inverse of each other, which is what inverse means, is the opposite of each other. The only one that I got some conversation yesterday through text message, and I understand where it's happening, is your quadratic, because a quadratic then turns into a square root function. A square root function does not exist in the negative. So your parabola, when it flips, you're only going to get half of it. So when it flips across that y equals x diagonal line, perfect, you're not going to have a full parabola on the other side. So when you're looking at whether it's correct or not, don't panic. It's going to be a little different. So in this case, it's 5, 3, so I have 3, -9. So then at -9, 3 should be the start of your other graph. And then we're only going towards positives, but let's grab another one. So 5, -5. So that means at -5, we're going to go up to +5. And then we're going to keep going this way. So 6, 0. So 0, 6. And you could almost, so that would be what you're looking for. You will not necessarily see the other side of the parabola. So that's the only call out where they shouldn't be an exact match across that line. And I believe in one of the videos I said it, because I always think about reflections and all the transformations and translations as like it's a piece of paper with really wet ink and you fold it in half, or like it didn't dry when you're writing on something plastic and then you touch something else and you get an almost exact imprint. That's kind of how I think about it, and it folds along that y equals line. So the other side of that line is where the imprint is. So again, long story long, if you type in your answers in Desmos or your predicted answers in Desmos, you should know whether you're right. I'm sorry, yes. Or I guess you would know if you're wrong as well. You can't always figure out how you're right necessarily. I mean, I guess you could go through trial and error, but you could definitely catch a wrong and go find your algebraic mistake in solving. So with that said, these guys were inverse functions, and the reason I pulled these is just because I think there's some operations that people have forgotten. Like inverse operations is as basic as middle school. So obviously addition, the inverse is subtraction, multiplication, the inverse is division, and then obviously these work back and forth, right? So the inverse of subtraction is addition, the inverse of division is multiplication, because you're undoing each. So squaring something, the inverse is taking the square root. And when there's no number in the root bar, that is assumed that it's a 2. So that also works for any other power exponential function. So if it's a to the third, then you're going to use cube root to undo it. And you always do those last. So in this case, looking at this guy, this -3 is on the outside. So, sorry, the instructions I gave you was to rewrite it, and that's because this is how my brain works. Without the h of x, because that is y. Now you're going to flip it and put your x and your y in opposite side, like opposite of what they were. So x goes on the outside, y goes on the inside. And now we're going to solve for y. So the idea is that we're trying to get y by itself. So we're going to add 3 to both sides, which means I'm going to have x plus 3 equals the cube root of y. Now, cube root is a little different because we're really used to doing square root, but ultimately, it's the same thing as square, except we're using a 3 instead. So it's what number times itself 3 times gives us the number underneath that bar. To undo it, you're going to cube this side, and we're going to cube this side. And that makes this and this go away. And so then we're back x plus 3 cubed equals y. Now, completely heads up, your answer could look like that, or they could expand it and go ahead and solve it. And by solving it, I mean like they're going to multiply this out if it happened to be a multiple choice style question. And once they box method FOIL distributed all 3 of those binomials, that answer may be the one you see. Again, in that case, what I would do is either try to multiply it out, or if you have Desmos up and you're comfortable, I would type this in and then go look for your answer choices that match. Type those in as well. Not to undermine practicing multiplication and all these fun things, but math 2 and forward, hopefully you've already got that pretty nailed down. And we always panic about time. From people, most students' feedback, when you have a time test or a timed quiz, it sends you into orbit. So save yourself the time if that suits you better, like if that keeps your stress level down, because stress level is a big deal in being successful on a quiz or a test. So the next one, we do have a fraction, which is why I did that on purpose, because that seems to make people panic as well. So first thing first, we're remembering that g of x is y. And then we always flip our x and our y positions. And now we're going to solve for y. So we're going to add 2. So x plus 2 equals 1 over y. Now we have a slight problem because y is in the denominator and we need y by itself. So this one's a little messy. We're going to multiply both sides by y because that is the inverse of division. I'm going to move over to the right-hand side. So I now have y times x plus 2 equals 1. Our goal is still to have y by itself. So at that rate, I'm not going to distribute it in because that just attaches it to more things. Because realistically, I want x plus 2 to go away. So I'm now going to divide by x plus 2. That makes this one go away. And y is now by itself. So there's a little more finagling on that guy. I tried to pick ones that weren't super, super easy for this review session. But again, it's just remembering your inverse operations, how to undo things, move things around, using PEMDAS, or please excuse my dear Aunt Sally, otherwise known as orders of operation, depending on who you had in middle school, what little fun memory hook they had for you. But as long as you have all that in line, and again, Desmos to check, inverse should be fairly user-friendly. Do you guys have any questions about inverse functions? And then I'll jump right into logs. Okay, beautiful. So, logs. First day, the most basic. And I love this because I feel like a lot of math and math 3 can get really complicated and kind of wild and hairy and fuzzy and all the fun things. This, as long as you memorize it, the swoops and the push downs and where things go and the verbiage, it's fairly easy. So it's log base of number equals output. So log base of whatever it is equals whatever the output of the equation is. So log base 6 of 216 is 3, is a sentence format. So log base, when you think of the word base, hopefully we remember that from exponential functions or exponents. It's the number in the basement is what I call it. It's the base number that we raise to a power as far as exponential, because logs are the inverse of exponential functions. To switch them, and as you guys already well know, I like to make up weird non-mathy things to remember things. If I'm going from log, and I'm going from log because log is there, to exponent, you always start at your base, and I'm going to make a cursive E. Cursive E. So log base 6 to the third power is 216. So 6 raised to the third power is 216. Is converting it from log to exponential. And this one, there's no variable, so it's just more practice. and working it out. The reason you need to be able to switch between the two is when you're solving for a variable, and the variable is in an inconvenient spot, and you can switch it back and forth. So again, you're going to start in the basement, make a cursive V, so grab your exponent, and come out with your output. So start in the basement, which is U, grab your exponent, which is 16, is output. So log to exponential, cursive E. Log to exponential, cursive E. So grab your base, start with your base, grab your exponent, and come out with your output. So base, grab exponent, out with your output. And last but not least, so again, base, grab exponent, come out with your output. N to the M power is 149. Now the reality is that problem right there is just a hot mess. Again, this is just practicing the converting between the two. It's not how they're going to probably live more times than not. So then convert to logarithmic form. All right, Abby, have a great day. So this is the opposite. You're going to make an L. It's a real ugly L, and this is a push because I feel like the E is beautiful. So you're going to push the base number into the basement of, and then end with exponent. So like I said, it's kind of a wonky looking L. So log base M of N is -2. So M raised to the -2 power is going to give me N out, right? So again, an ugly L. Push the base into the basement of 625. Exponent is after equal. That's the other way that I've memorized it. So exponent is after equal marks, and that's the double E's. So log base 5 of 625 is 4. And it doesn't matter how ugly they look. I mean, it is just that exact pattern. So even with a fraction and with double variables on one side, push our base into the basement, grab our of, and then end with our exponent. So log base y of 7 over 18 is x. Again. And then, so evaluating logarithms. This is really silly, but because I'm a teacher and we're supposed to learn the things. This is called change of base, and I say this because I don't want you to go to another math class and then all of a sudden you're like, oh, okay, there's that. I've never heard of that before. Change of base is what this is, the way to solve these without a calculator, without Desmos. So that means whatever's in the basement stays in the basement. So log of 4, and then whatever's on the top or just online stays on top. When there is not a number in the quote-unquote basement, so log base nothing of 16, log base nothing of 4, it's not nothing. It's an assumed 10. So kind of like, what is it? Square root, like the square root, where there's an assumed 2. If there's nothing there, it's assumed 10. It's not 0. So it's log base 10 of 16 divided by log base 10 of 4. Because on a TI-83, your log button has an assumed 10. It is just the clean version. And so you can write log 16 divided by log 4. There are some TI-84s, and 3s and such that have the programming where you can change the bases, and you can literally type in log base 4 of 16, hit enter, and get an answer. Desmos, absolutely, log base 4 of 16, and get an answer. But worth the conversation again, because I don't want you to ever to walk into a classroom or another place where they're talking about stuff and you're like, nope, never heard of that, which we may still forget because we're not going to cover it a lot. But the change of base is where you stack them so you can use the log base 10. And in this case, the answer is 2. So it gives you, there's really no math. You're not doing any math. They do it. Right? So change of base, and just as far as that's concerned, as far as setting it up, again, whoever's in the basement stays in the basement. So log 3, log 27, type in your calculator, get an answer out. But one more time for those in the back, with Desmos and the accessibility we have, you can actually type this guy in directly into the calculator, and it will give you the answer. So the change of base is just sort of for the back of your brain to make sure you're tracking all the things that could come at you in the future. So again, log base 10, top and bottom, basement in the basement, straight line on the top line. Now, getting into solving logs, because that is what our assignment is for today and what you're learning today in class and with your notes. And now I can't put my hands on them. Hold on one second. I'm so sorry. I had them all, and now they're gone. Well, that's not cool. Sorry, Ava. I was so prepared today, too. Ha! Oh, no. I tucked them away. So solving logs is why you need to know how to be able to convert them between exponential and logarithmic. So just so you know your why of what you're doing. There's a couple. We don't get into any of the major rules. Those come later in Math 3. We just do the basic stuff for right now. So it's actually fairly easy, and in my opinion, if you like solving equations, not that difficult. So these are my most favorite because they're really basic. So if you have an equation with log base the same, so in this case log base 10 on either side of the equal marks, they cancel each other out. And then you end up with just negative x plus 5 in this case equals 24. And you solve it like a standard equation. So since we're solving for negative x, make sure we're holding on to that negative x because the negative is easy to slip away. Negative x equals 19. And then obviously this is not x equals 19. We want to divide by negative 1 to make sure that x is positive when we're done. So x equals negative 19. And they have to match exactly. The bases have to be exactly the same. So looking at number 8, they're log 19, perfect. They're gone. 5 equals 2n minus 8. Solve it like a standard equation. Back from Math 1, even at arguably 8th grade. So we're going to add 8 because that is the inverse of that subtraction. So 5 plus 8 is going to give me 13. And then 2n are going to divide by 2. And it's going to equal 13 over 2. And we can leave it as a fraction. Or if you're doing delta, you do whatever the teacher, website, test, worksheet, the kind of formatting they want. Because there's not a hard line. They're both correct. 13 divided by 2. Or it would be 6.5 as a fraction. As a decimal. Both are correct answers. I personally will accept either. So again, like number 9, they're both log 11. Get rid of those. This guy is ugly because we see that quadratic, which means we have some real math to do. So not Math 1 level equations necessarily. We are getting into real quadratics here. As soon as you see that v squared, know that you're going to try to get this whole thing set equal to 0, and then you have to factor and solve. So factor and solve. So I'm going to v squared. I'm going to add 2v to both sides because I'm going to come over towards the v squared part because it is already positive. So minus 6v, that turned into an x, sorry, equals 40. I want the 40 to come over, so v squared minus 6v minus 40 because it was positive on that side. And now I can factor or get to solving at this point. For factoring, if we want to use our big star, if you want to use little star, whatever you normally use, negative 40 on top, negative 6 on the bottom, 1v, 1v. I'm going to use 4 and 10 from 40 to give me 6. I need a negative 6 and a negative 40, so that means that my b value is negative, so the largest of the two definitely has to be negative. So it's going to be v minus 10, v plus 4. And then you're going to set both those equal to 0 to solve, which is going to give me v equals a positive 10 and v equals a negative 4. So our answer to this guy would be negative 4 and 10. And those are not parentheses. They're the squiggle because it's a list of solutions, not a coordinate. So a list of solutions, not a coordinate. Now, they get a little more fun, but not that much different than things we've done already in the past. So you think about absolute value, which we did last. The idea is getting your absolute value by itself and then doing the magic that absolute value requires. So same here with our logs. The idea is getting log base of those 3 portions of the log by themselves. And then we can switch it around because as soon as you have a variable attached to the log, like in this case, that R is over there on the side with the log, you can't use your calculator with the log button. So it needs to be an exponential form to be able to solve it. But log base 12 of, we have a negative 7. It's in the way. So we're going to divide each side by negative 7 because it's attached by multiplication because there's no sign between the 7 and log. So these are now going to go away. 0 divided by negative 7 is still negative 7. So now I have log base 12 of 4r equals 0. So just like when we were converting them around and moving them and using our cursive E's and our funny looking L's, in this case we are going to an exponential form. So 12 to the 0 power is equal to 4r. So 12 to the 0 power is equal to 4r. Now we have to remember our law of exponents, or again, the beauty of this, use your calculator. Please use your calculator. 12 to 0, so that any number to the power of none is 1. So power of none is 1. So this whole thing just becomes a 1. We need to get the 4 off the r. That's attached by multiplication, so we're going to divide. So r is 1/4. And then ta-da, you're done. All right. So look at number 11. We have log base 4 of 5v that we need to get by itself. Those are our 3 parts that need to be by themselves. We have a negative 8 attached in the front by multiplication because there's not a symbol. So we're going to divide both sides by negative 8 first. So log base 4 of 5v is 2. Negative 16 divided by negative 8 is a positive 2. Our v is over here on our log side, which is bad news bears. So we're going to pick up the base, go grab our exponent, and come out with an output and put it in logarithmic form. in exponential form. So 4 squared equals 5v. So 4 times 4, because that's what 4 squared means, is going to give us 16. 5v. It's 5 times v, so we're going to divide by 5. And that's going to give me 16 over 5 for v. Or it can be 3 1/5 otherwise. Which we could write it as a mix, but I have not seen a lot on our level math written as a mixed number like that. It's usually your fraction or a decimal. I'm okay with fractions for right now. So that way we can become friends with fractions. So since we're at we're closing in on our time here, I'm going to skip 12 because it's exactly the same problem. Again, log base 11 of negative 16 equals negative 5, but that 5 on the outside is our problem, so we're going to divide both sides by 5 and then boogie straight through like the 2 prior. See if I got us some extra ones that are a little different. Yes. All right, beautiful. So this guy, log base 3 of r minus 8 is negative 4. Our problem is our negative 8 here, but there is a plus, so it is attached by addition. We need to move that negative 8 by using its opposite. So we're going to add 8 because it is a negative 8. And then I know a log base 3 of r minus 8 equals a positive 4. Again, our variable is on the side where log is, which is a hot mess. So grab our base, grab our exponent, come out with our output. 3 to the 4th equals r minus 8. And 3 to the 4th is 3 times 3 times 3 times 3. So it's 3 times itself 4 times. 3 times 3 is 9 times 3. Let's see. 3 to the 4th. Whoops, that's not it. Is 81. So 81 equals R minus 8. We're going to add 8. So R equals 89. Exponential. So when you have your X in the exponential spot, and I'll only do one of these because, like I said, we're running out of time. And if you need me, holler. You're going to change each one of these to logs, right? We're going to change it to logs. So, I'm sorry. When the bases are the same, we can cross them out too. I about just messed up. For exponentials, when the bases are the same, they can go away. So it ends up 2x equals a negative x. If I move that over, 3x equals 0. X is going to equal 0. So when the bases for the exponential are exactly the same as well, you can cross them out and just use your variable exponents to solve. When you do not have two like bases, then that's when you want to switch it to log form. So again, using that ugly L, push the base into the basement, and then end with our exponent. So log base 4 of 1 equals 3r minus 1. And that's where you're going to type in log base 4 of 1 or log 1 divided by log 4, whichever one suits you. And that gives me 0. Log base 1 over log base 4 gives me 0. So 0 equals 3r minus 1. We're going to add 1 to both sides to get r by itself, or work towards r by itself. And that's 3 times r. So we're going to divide by 3. And r equals 1/3. So we'll practice more of the solving exponentials as we get along. But again, if the variable is in the exponent, that's when you're going to use logs. And you're going to use your calculator as much as possible. It is not assumed that you're going to be able to do this without a calculator at all. Welcome to Math 3, love of calculators.